Yo, okay, live again for day 8 of interview prep. I'm going to be solving some LeetCode questions today. Probably start off with a little bit of Clash of Code. Maybe also then look at some of the coding interview questions that they have on Algo Expert. Is the music a little loud, or is that just me? Hold on a sec. Okay, not sure what changed about that because I was using the same settings yesterday. The coding interview questions that exist on Algo Expert. The good news to share is that I passed my Amazon phone screen. Which was yesterday, so I'll be moving into the full round of 5 consecutive interviews in the same day. So like 5 straight hours of interviews, and I have to schedule that. That's a ways out, so well, it's not a ways out, but I'll schedule it a little bit out so that I have even more time to prep. And yeah, all the prep work will be live on Twitch as well. So I think that's all I have to say as far as introduction goes. Let's go ahead and look at Clash of Code. Okay, so hold on a minute. Let's try to join a Clash that has a few more people in it. So for anyone who doesn't know, Clash of Code is like tiny little coding contests. They usually last like less than 10 minutes. You just solve a problem really quickly. And yeah, so it's kind of a nice way to just kind of warm up before going into the meat of the stream. The meat of the stream. This guy, I see this guy in here a lot. I don't know who this is, but this Tykorg. He seems to always be clashing. Like, I have no idea. Does he just clash all day long? Is that what he does? Anyway, let's see who else we get in here. We got blue screen of death. Great blue screen of death. Okay, cool. We're filling up. We're filling up. So we got 7 out of 8 players. Let's hope we get one more so we can play around with the full 8 players. Oh, wait a minute. I messed that up, didn't I? I was supposed to launch the clash when we had everyone in there. Because I guess I was the host. Alright, so what's this? Given an integer m, find the biggest integer n we can obtain with the same number of 0 and 1 as in the binary representation of m. So if you get 5, which is 1, 0, 0, 1, 0, 1, the largest one we can get is actually this. So we can actually take the binary representation, sort it in descending order, and then convert that back to an integer and then print it out. How do you do that in JavaScript? JavaScript string to binary. I don't have that memorized, unfortunately. Int to binary string. You tell me there's not a built-in way to do that? Hey, what's up, Gigantic Bucket? Thanks for hopping in. Good luck with the codes. Well, I'm already doing bad. Well, no one else has submitted yet, but I need the binary representation of the number, and then I need to sort it. So, man, let's just do it manually, I guess. It doesn't look like there's a util function. We'll just call it const bin equals this. Oh, I was actually, you know what? I've been thinking about bubbly troubly, by the way. I've been thinking about it. I'm not sure I'm quite ready yet to actually go for it, but we'll see. While n is greater than 0, bin dot push n mod 2, and then n equals n over 2, and then we floor that. Okay, 2 people have got it accepted. There's probably a nice util in Python that you can use to get this. Well, let's just see if we can get it in JavaScript since we already started. Yeah. We got 101. Hold on a minute, but does that work for everything? Like, does that work for 12? 12, we get that. Wait, so is this just right? Did I just write that correctly the first time? 1011 for 13. So we can also have, maybe we can just calculate the answer as we go. Answer, oh no, because we do need to sort them then. So, so after we get the binary representation, which I'm still surprised that worked first try. N equals 10. One zero one zero. Okay, I haven't written this algorithm in a while, which is why I'm a little surprised that that just works. So then we need to sort them. So bin.sort. So we sort it, and then what we're going to do is iterate through these, and we're going to build an answer. N equals, let x equals 0, and x is what we're going to print. For const y of bin, how's this work? I need a bit shift, right? So if y, then x shift over by oh, okay, so if y, I can do x or equals 1 to set a bit at the end, and then I just do this, right? X shift over to the left by 1. Oh, we failed. Okay, we passed 3 test cases. We missed a test case. Test case 4 we missed. Found 6, expected 24. Does it not tell you what the input is? Oh, wait, why is it so hard to get to this information? So test case 4 is 17. So for 17, what would the binary be? 1. So there'd be a 16, no 8s, no 4s, no 2s, and a 1. And then what you want to get is a 16 and 8. Okay, so that makes sense. That looks right for 17, but our code is not producing that. So let's do this. N, let's just force n to be 17 while we figure out what's wrong. So after we sort the bin, let's see what we get. Can you reverse an array? Is it just that it's backwards? Is that what the problem is? Okay, so it's definitely getting shifted 1 too far now. It's becoming 48 instead of 24. What's the problem here? So we go through all of the numbers in the binary representation and we set a bit. Oh, I think we're just supposed to shift first. Okay, so we got 24. Okay, and I'm not supposed to be logging that. Okay, that looks right. That looks right. Okay, so we solved them all. Solution is pretty straightforward. First, convert the number to its binary representation, which I couldn't find a nice util for in JavaScript. I'm sure that in other languages, that's probably just a few keystrokes away. You sort the binary representation so all the ones are together, and then you reverse it just because of the way that this is written. We want the ones to be at the beginning. Then you go through the representation, and you just set bits in the answer based on where the ones bits are in the array that you created. So I'll share the code. The person who solved it in first place solved it in less than 2 minutes, and they shared their code, so let's take a look. So they input, then okay, yeah. So there's this util in Python where you can just turn a number into its binary representation, and then turn that into a string, and then they substring that from the second index, and that's probably because it starts with a 0x in the string representation. So then once they have the string, what do they do? They count the number of ones. Oh, okay. So yeah, they're doing the opposite. They're generating a string with all the ones at the beginning and all these zeros at the end, and then they're converting it to integer. So they're basically telling the int function, interpret this as base 2. So yeah, that's kind of what I wanted to do, but I didn't know how to do that right quick just in JavaScript. But either way, I'm happy that I was able to code together a actual bit manipulation solution. So let's play again. You want to join? So I know it's possible to do a private clash, but and like that's something that I do want to do like with viewers. However, the way I was thinking about it was that it would make more sense to do private clash once there are more viewers who want to participate. Oh, you're showing me the JavaScript solution that I wanted to do, but I didn't know how to do. I thought you were asking to join the clash, which would have been fine. It would be nice if like you and I could queue up with other people who are playing. I don't know if I would want to do just a 1v1. I mean, it's not that I'm scared. Like I'm fine with losing 1v1 to someone who's more experienced than me, but I just don't know if it would be as fun as doing a clash with more people. But honestly, if we hit the join clash button at the same time, that might actually work. But before we do that, let me take a look at the same lobby. Yeah, no, I'm actually pretty hyped that you want to play. Sure, yeah, absolutely. So hold on, let me just observe something for a second. Here's what I want to observe. I mean, it's pretty much what I expect, but oh, okay. So you can do. See, this is what I thought existed, and I couldn't find it. But yeah, that's exactly what I was talking about. Sort, reverse, join, and then parse int. Okay. So basically what I need to remember is that you can pass in the base that you're dealing with into the toString function. I forgot about that. And then the same thing for the parseInt function. Very nice. Very nice. Okay, let's go back to here. So how do we join the same? Oh, challenge friends. Well, we should be friends. How do we be friends on this website? Friends. Search by nickname. What's your nickname? Mine is the Snups. Oh, here, look, I could just share this link. Also, coding game still uses something called servlets. I thought that was, I thought servlets were out of date. I don't know, maybe I'm just completely wrong about that. Okay, gigantic bucket. I got you. Okay, so Clash of Code. Okay. So can we join the same lobby just by joining a clash at the same time? I'm gonna join. I'm gonna click the button. So there's a stream delay of like a second or two. So I'll let you take that into account however you want. So I'm gonna click the button on 1, 3, 2, 1. Probably doesn't really matter that much. Oh, I can invite you right here. That's smart. There we go. I see you. I see you in there. The reason, there's actually a very specific reason I have a leopard for my profile photo on this website. And it's because there's a streamer that I used to watch a lot. I haven't watched him too much recently. I'm not sure how much he's still streaming, but his name's Larry. He does a lot of like competitive programming, and he streams a lot of, he like has a lot of YouTube videos for LeetCode problems and stuff. And so I was clashing in his Twitch channel for a while, and so there was just a meme that everyone had to have a snow leopard as their profile photo. Okay. Let's see. Ooh, I got it. I got it. 2 people got it faster than me, though. I'll wait for you to be done, and then I'll look at some of the solutions that people posted. Nice. TypeScript. Okay, let's see. So Noxy, who got it real quick. Oh wow, okay. So they used the reduce function. Oh, so in Ruby, you can just call a digits function on a number and get the digits out. Oh yeah, okay, you're good. And then they use reduce, and they basically use reduce, and they're passing like the multiplication operator to reduce the elements together. I used reduce in my solution as well. Let's see, this person just wrote a straightforward for loop. I need to, hold on, I should increase the text size on this website a bit. This is what I did. So convert to a string, split, and then reduce, starting with 1. Also, don't forget to hit the share code button. When you do that, people can click view code next to your name. I've never found a reason not to do it. What did this guy do? What in the world? What in the world is this? Okay, well, first of all, I don't know Go, but this code just looks very complicated for the task. ASCII to int. Panic. Well, anyway, that seems to work. Okay. Do you want to play again? So one of the things that does bug me about Clash of Code is that they have some different modes. So they have fastest mode, which is what we just did. Oh, okay, all good. They have fastest mode, which I like. They have reverse mode, which is where they show you input and output, and you have to figure out how to write a function to convert. But then the mode that I don't like is they have this shortest mode where you win not by how long it takes you to get a solution. You could literally take the whole, like, whatever, 15 minutes or whatever that they give you. But you win by having the fewest number of characters in your final solution. And so people find some ridiculous ways to shorten stuff. And it just, obviously, the result is that the code becomes completely unreadable. But it is also kind of a nice showcase of, you know, some of the ways you can shorten code in different languages. Like, usually, like, Ruby ends up winning, I've noticed, in the shortest mode. Chat count is pretty language biased too. Sorry, I don't follow. What do you mean? Yeah, char count, yeah. Yeah, that's what I mean. It's language biased. Like, if you're writing your code in Java, you're never gonna win. But I have seen winning solutions come out of, like, Ruby, Python 3, and also C every once in a while, because in C you can getting input in C is really quick using scanf, and it's not that many characters. So if you need to read like 5 integers and they're all on their own line, scanf lets you do that really easily, whereas other languages like in Python you'd have to do like input, or you could put it in a loop, but it's still shorter to do it with scanf. Yeah, so yeah, have fun with the doggo. I'll play another one, and then I'm gonna browse LeetCode and try to find something interesting to do. Oh, shoot, it started fastest mode. Integer n for the number of tables he reserved. Integer percentage for the percentage of the bill he needs as tip to get drunk. Next n lines are 2 space separated floats, bill for the amount of the bill and tip for the amount of the tip. I didn't read the top here. The waiter Nicky daily works for a pittance. After a hard day, he wants to treat himself to a drink, but he can only afford that with a decent tip. So if he gets more than a certain percentage of the tip in total in one day, he can drink until he forgets the fucking job. Okay, so what's the percentage? Oh, I see. So the bill and the tip. So is it the sum of all the percentages? Or is it the average percentage? In total. Oh, in total. So you're summing all the bills and all the tips. So let bill sum equals 0. Let tip sum equals 0. Bill sum plus equals bill. What the hell? Can I type? There we go. Bill tip sum plus equals tip. And then console.log, and we'll do a ternary. If tip sum divided by bill sum, so it's going to give us a floating point number. If it's greater than the percentage, then drunk, otherwise thirsty. Is that right? Just make sure this is correct. So, less than or equal to. Tip sum. So, the bill is 10. The tip is 1. So that's a 10% tip. So that should work.
Sorry, I'm
Alexa,
not sure about that.
Shut up. This is kind of annoying. What's wrong here? Let's look at the bill sum and the tip sum and the quotient of those. .1. Oh. Okay. Bill sum divided by tip sum times 100. Fuck. Some people got it. This should work. Oh, it's shit. Yeah, you gotta remember to remove your console logs. Okay. That's dumb. I think I actually could have got first place there if I had, well, if I had done it a little bit faster, which I think I could have done, but that's fine. We got second place. Let's see. Jasmine Hart solves it in Python 3. And let's look at the code. Yeah, same code. Some of the bills, some of the tips. 100 times the tips divided by bills. If it's greater than or equal to the percentage, then you're drunk. Otherwise, you're thirsty. Pretty straightforward. Oh, hold on a sec. I'm just checking a text. Okay, so one more clash maybe? Hold on. So Isa solved it in Python 3. I bet it's going to be pretty similar to what we've seen. Yeah. Okay, I might do another clash. So let's just browse LeetCode for a second here. I want to do some problems that require the use of monotonic stacks, because that's monotonic stack is a technique that I need to work on a little bit. So I selected this problem, next greater elements, because it's easy and it uses monotonic stacks. So let's have a look at the problem description. So the next greater element of some element x in an array is the first greater element that is to the right. Okay, so if I have an array where the numbers are like 1, 3, 2, 5, -1, 5, 12, 6. I don't know, maybe it starts off with 98 or something like that. So 98 has no next greater element, right? I think that's what it's saying. One's next greater element is the 3 right next to it. 3's next greater element is the 5. 5's next greater element is the 12, because the 5 is not greater than it's equal to. Okay, so moving on, you were given 2 distinct 0-indexed integer arrays, nums1 and nums2. Oh, I'm still getting dings from Clash of Code. It's just telling me... Wait, what? How did I get... Oh, this clash hasn't finished yet. Look at my rank. Top 3%. So my rank was actually better than this yesterday. My rank jumped from like 100,000 all the way up to 4,000. And then I guess what happened was I did a couple more contests and it had to, it pulled my rank back a little bit because it was too high. Anyway, so what are the rank statistics? We're gonna get you guys won't get it, but I'm gonna get one more ding from Clash of Code once that last person finishes the most recent clash that we were in. So what's the problem then? You were given 2 distinct 0-indexed integer arrays, nums1 and nums2, where nums1 is a subset of nums2. Okay, it's a subset, but it's not a subsequence, because I'm looking at example 1 here, and the order of the 4, 1, and the 2 do change. So let's just put let's make a subset of my array here. Let's have I don't know, 5, 98, and 12. So there's the subset. For each index I, find the index j such that nums1 of I equals nums2 of j, and determine the next greater element of nums2 of j and nums2. Nums2 being the larger one. If there is no next greater element, then the answer for the query is -1. Oh, I see. So each index is a query. that you have to answer. So that means that we're producing our answers here, which will be returned at the end. So for int I equals 0, I is less than n. Oh, I have two arrays. So the array that we're iterating through is nums1, which is the subset. Nums1. I'm just going to change these to A and B, just because that's going to shorten the code a little bit. A.size plus I. And okay, so for each index I, find index j such that nums1 of I equals nums2 of j. The numbers in I are guaranteed to be unique. Yeah, they are. So this is already not possible. I had 2 5s in mine, but that fixes it. So this is, I don't know, I feel like they just kind of threw this part in here to make it a little more interesting. Like, what are the sizes of these? Because I think I just create a mapping, right? I just create a mapping of the numbers in nums1 to where they are in nums2. Yeah, so I'll create a mapping to what the indices of the numbers are in nums2. So it'll be like unordered map of int indices, and then for int I equals 0, I is less than nums2 dot size plus I. Then we'll store the number and its index. So nums2 sub I equals I. Hold. Okay, so we're iterating through the numbers in okay, hold on. So this is supposed to be B. We're iterating through the numbers in A, and now we need to know where it is in B. So the way we do that is we look up the index like this, A sub I. So that's the I and the J as they're defined by the problem description. Now we need to determine the next greater element of nums2 j in nums2. So okay, so the naive solution is to just search for it, but we need to implement it using a monotonic stack instead. But it would be, naive solution would be while j is less than b dot size. While plus j. So while we'll just do it this way. While j is less than b dot size, we should start it off at one higher. If b of j is greater than a sub I, then break. So then we have the j, and so then answers dot pushback. We'll have a ternary, and if the ternary is true, it'll be j, otherwise it'll be -1. And the ternary is that j is less than b dot size. And b of j is greater than a of I. Oh, time limit exceeded because we do need to increment j in that loop. Okay, so what? So the -1s are right, but I'm saying 1 when I should be saying 3. Oh, it's the index, b of j. Okay, so this is not the right answer because I'm supposed to use a monotonic stack here, but if I submit, it does get accepted, but it can be faster. So monotonic stack is, I'm trying to refresh my memory on the idea. It is a stack where the elements of the stack are ordered. So if you were trying to find the next greater element of 98, well, okay, so I think the idea is that if you need to find the next greater element of a specific number, then I don't think the monotonic stack helps. You just iterate and find it. But because the thing is, because the question requires you to find the next greatest element of everything, then I think you use the monotonic stack to pre-calculate all of those. So I iterate through B, and as I'm iterating, I'm making use of the monotonic stack. I don't quite know how yet, but I think that's what I'm supposed to do. And I keep track of what the next greatest elements are of all these, and then once I have that, I can iterate I from. Basically, I can do the same problem, but I would be able to look up what the next greatest element is in constant time, rather than needing to do this, and that will improve the efficiency of the solution from, I guess from n squared ish down to n. So let's create a new vector. of ints, and we'll call it NGE, next greater element of size b dot size. So this part right here is store where shit is in B, and then this right here is create NGEs, or determine NGEs for B, and then once I implement, once I actually build this array, then instead of having a while loop here, I just do answers.pushback NGE, or sorry, yeah, NGE of J. So we need to do this. So how do we use the monotonic stack to create the next greatest element? So let's say that we start at 98. Or do I start from the end? Like, how do I know what the next greatest element of 1 is? So basically I would want to be able to like pop off the stack or something, right? So let's see. Let me just try to reason through this. So I come in, I'm at index 0. Next greatest element of 98. Unclear, because there's nothing on the stack yet. But I put. Wait, no. Okay, so do I do this from the back to the front? Let's do it from the back to the front. So 6 has no next greatest element. So it's just -1. This will be NGE. Sorry, I keep making GNE. NGE. So I'm populating the next greatest element from back to front. 6 just doesn't have one, but then I also have my my stack, and so for the stack I'll push 6 onto it. Right? 6 is the greatest element that we know of that could potentially be next greatest element for some element before it. Okay. Then the next step is we come to 12.
Sorry,
Alexa,
I don't have an answer for that.
Stop. Man, I really got to turn Alexa off during the streams. Or at least turn the volume way down. Nick.ht, thanks for being in the chat. And yeah, she just keeps thinking that I'm talking to her when I'm not. Okay, so 6 does not have a next greater element, so we put -1 in the next greater element array, and we push 6 on the stack because because it could potentially be the next greater element of some element before it that's coming up. So then we go to 12. So we look at 12, and now we have 12, and we have our stack, and the thing is, the top of the stack is 6. So I think what we end up doing is popping that off the stack. The stack is empty, so this becomes -1, and we put 12 on the stack. Yeah, that's gonna work. So then we move forward again to -1. We're at the third to last index in the array, and we look at the stack to see what the next greater element is. 12 is on the stack, and -1 is less than 12. So we put -1 on the stack because the NGE array still becomes 12 here, but we have to put -1 on the stack on top of 12. So so the front here would be the top of the stack, because -1 could actually still be the next greater element for something coming up. Looking ahead, knowing what we already know, we can see that it's not going to be, because as soon as we get to the 5, but yeah, so that's what happens next. We come through, we look at the 5, and we look at what's on top of the stack, right? What's on top of the stack cannot be the next greater element because it's less than, so we pop it. And that means that 12 is the next greater element of 5, and then we put 5 on the stack. And so this is going to be a linear algorithm because at most every single element of this input array is going to be pushed and popped off the stack once. Okay, so I think that'll work. That kind of makes sense in my brain. Let's try to implement it. So stack, I don't know. So let's just call it mono because it's a monotonic stack. We don't give it a size. Okay. So next we iterate backwards through the array. So I equals b.size -1. I is greater than or equal to 0. Minus I. Okay, so first things first, if the stack's empty, if not, or sorry, if I can just do if mono.empty, then NGE, next greater element of I equals -1. And we push this onto the stack. So mono dot push b of I. Now, if the stack is, and then that would be it for that. So we could continue there. So I don't think this is final code. I'm just kind of like writing it how I'm thinking through it, and then we'll probably end up like rewriting this so that it's a pretty straightforward loop that we need to do. So if it's not empty, what do we decide down here? So if it's not empty, we need to pop off the stack until the top of the stack is greater than this number. So while mono.top is less than or equal to, so in this case it's monotonic, means that it has to be strictly increasing. There's no numbers that equal each other on the monotonic stack. And furthermore, it's actually not possible because they guarantee in the problem description that all of the numbers in the input are unique. So if so basically we're popping off the stack until the stack is either empty or what's on top of the stack is we want it to end up being greater. So while mono.top is less than or equal to b of I, we pop. So mono.pop. Then what we're going to end up doing at the end is pushing b sub I on to the stack. Mono.push b sub I. But first, okay, I think I kind of see what I need to do now. So we keep popping off the stack either until it's empty. So basically while mono is not empty and the element on top is less than or equal to the current number of the array, right? And then once we finish doing that, we have to update NGE of I. So ng e of I equals mono.size or mono.empty. If it's empty, then -1. Otherwise, it's not empty, and the next greater element is what's on top. So I think that enables us to get rid of all this. And then the last thing we do is we push the current element on. Is that right? Run code. NGE right here. Submit. There it is. So that increased our runtime from 15 milliseconds to 8 milliseconds. Yeah, well, we're going to take a look at the solution page to make sure that we've got it pretty optimized. But it looks like that's correct. Also, there's these follow-up problems that I might take a look at too. Oh, Nick Dot, thanks. And thank you for the follow. Appreciate that. First follow of the day. Pog. Yeah, I haven't, so monotonic queue or monotonic stack is a technique that I need to review. I haven't done it in a while because I'm doing like interview prep, so I'm pretty happy to have gotten that one. I just want to review though how I did it. So we have our monotonic stack. It's keeping track of, as we're going through the array backwards, the array that we're trying to figure out the next greatest elements of. It has in ascending order all of the next greatest elements in ascending order. So then once we're at an index, we just need to pop off until we find one that's actually greater, and then that's the next greatest index. Oh, TypeScript. Yeah, sweet. I think LeetCode, yeah, LeetCode has a TypeScript language that you can use. So what's your background? Are you big into LeetCode? Are you also grinding out for job interviews? Okay, so I want to look at the solution. So brute force. This is the first code that I wrote and it worked. This actually does get accepted, even though your solution is m times n, so it's quadratic. And then approach 2, better brute force. Oh wait, this is like super brute force, I guess. And then if you create the hash map that stores where the indices of stuff are in the nums2 array, then you get what they call better brute force. But the time complexity doesn't change though. And then approach 3 is using the stack. So I'm going to read through this part. In this approach, we make use of pre-processing first so as to make the results easily available later on. We make use of a stack and a hash map. Map is used to store the result for every possible number. Yeah, okay. And now we will look at how to make the hashes. Okay, so we iterate over the nums2 array, and we push every element nums2 sub I on the stack if it is less than the previous element on top of the stack. No entry is made in map for such nums_i. Okay, if we encounter elements in nums2 sub I such that it's greater than the top of the stack, we keep on popping all the elements from the stack until we encounter something on the stack that's greater than it. Yeah, that makes sense because well, first of all, you need to find the next greatest element for the one that you're looking at. But also, all those ones that you pop off can no longer be the next greatest element for something that you're going to look at later, because you know that you know that nums2 of I is greater than all of them, and that's why you're popping them off the stack. Thus, an element is popped off the stack whenever a next greater element is found for it. Therefore, the elements remaining in the stack are the ones for which no next greater element exists. Yes, that makes sense. So here's the code. That's probably going to look pretty similar to what I did. Yep. And then you reduce your time complexity to linear time. Yeah. Okay. So that was a good one to start with. Hold on, let me read the Twitch chat. I don't know Java, not prepping for interviews either. I use LeetCode, but not much these days. I'm currently more focused on web and mobile dev, but I'm gonna keep checking your streams out to stay sharp. And I'll go, oh, thanks, man. So the good news is that my streams, I think my streams will always have some LeetCode, but it's gonna get to the point where I'm probably just gonna be streaming either the contests themselves from LeetCode or streaming like a recap. I don't know if I'm technically allowed to stream my performance during the contest, so I need to check into that, but I would like to do that if it's an option. But after I finish the interview prep grind, and by finish I mean find a new job, I'm gonna start streaming different types of web development too, because that's what my work experience is in. So I have some side projects and stuff that I want to code in React and HTML, CSS, JavaScript, all that stuff. So, but for web and mobile dev, what are you working on right now? So do you do web and mobile dev for your full-time job, or is it mostly on side projects? Thanks, man. Yeah, there's more coming. I've wanted to start streaming software-related topics for a while, and I just haven't. But it's happening now. Full-time, been at it for over a decade. Wow, that's a long time. That's a lot of experience. What are your go-to what's your go-to stack for web dev-related projects, at work or at home? If you could choose the greatest stack of all time for your next project, what would you choose? Also, I did start off the stream with a little bit of Clash of Code. I think I'm going to be doing that regularly, but I'm probably done with it for today. Let's look at some other problems. So I opened up these follow-ups to the next greater element problem, next greater element v2 and next greater element v3, and I'm probably going to look at these today, but instead of jumping right into those, let me take a break from the monotonic stack and look at a dynamic programming problem. So I'm slowly making my way through the dynamic programming study plan. So I've solved a bunch of these sort of beginning dynamic programming problems, and I'm all the way up to so we solved maximum subarray yesterday. That uses a very common algorithm called Kadane's algorithm that I remembered how it worked, so I was able to solve that one pretty quick. But now I want to take a look at this problem, which is the maximum sum circular subarray, which I think is basically the same problem, except that your sum is allowed to, your subarray that is maximum can start somewhere in the array and pass over the end and wrap back around to the beginning. So that adds an interesting little twist. And then there's the maximum product subarray. I might take a look at that too. When it comes to the web and mobile, it's primarily TypeScript, Next.js, Chakra UI, Prisma, Postgres, React Native, Expo, Figma, Docker, Kubernetes, and more. That's a big stack. So I'm assuming you're a full stack developer then, since you're reaching into the back end with your tech stack there. Next.js, I know about that. I know TypeScript, I know Next.js. I don't know Next.js, but I know what it does. It seems pretty awesome. I don't know about Chakra UI and Prisma though. I want to check out what those are. And it's cool that you're also into systems programming. I like to whip out the old C every once in a while. I don't do any systems programming, but I learned C back when I was in college, and sometimes I'll do C or C++ for like LeetCode problems and stuff. So Chakra is create accessible React apps with speed. Chakra UI is a simple, modular, and accessible component library that gives you the building blocks. That sounds sick. Do they have a reference? Oh, they got a styled system. So that's really nice that they just have that as part of the library. And then components, let's see. Accordion. I want to see an example. Oh, it's got the animations built in. And it automatically closes. Yeah, this is sick. I might look at this for future projects as well, because it's, as I'm sure you know, having a library like this saves a lot of time building stuff like that from scratch. They got a drawer. Cool. Ooh, it looks nice too. So since you're using React in your stack, what's your state management solution? You're a Redux guy? Oh, Prisma, that's the other thing I was going to look at. Next generation Node.js and TypeScript ORM. Oh, okay. So this, I'm assuming this ORM. Yeah. Okay, I see it right here. It says it integrates with Postgres. So that's how you would like implement your DB updates, right? And your lookups, you would use Prisma, and then it would connect to your PostgreSQL instance and stuff like that. That's pretty cool. I prefer the context API, but if necessary, I use Redux. That makes sense. I remember back in the day when there wasn't a context API though, and there was like the shitty like old context API, and like now they have the nice new one. And so yeah, Redux did solve a lot of problems back then, but nowadays, as you pointed out, you don't really need it as much anymore. I do like the middlewares though that you can do in Redux that are a little bit less trivial to do in the context API. Okay, so let's look at this problem. Given a circular integer array nums of length n, return the maximum possible sum of a non-empty subarray of nums. Oh, you know what? Yeah, so this is the same problem. This is the same problem, except that the subarray that is the solution could span like across the end because it's circular. I wanted to show you this. So I have a small little side project that I started working on a couple of months ago, and I've taken a break from it, but I do plan on coming back to it. So if you're familiar with the game Wordle, which I think quite a significant portion of planet Earth is at this point, I created this game called Exertle. So if you go to exertle.net, you can play. It's very similar to Wordle, but with some differences. So basically, I can like guess my word, and the solution can actually be any length. It's not just 5-letter words like Wordle is. And so since the solution can be any length, you get additional hints. So for the yellow letters, it gives you an arrow telling you what direction the letter needs to move. And then also, both your green and yellow letters can get these yellow stars. And all that means is that there's more instances of that letter in the word that you need to incorporate. So let me go to the unlimited mode and try to just solve one real quick. So, okay, so this looks like it's going to probably start with DOR, right? DOR. Door. Or it could be like something ORDIN. Yeah, this is an original idea. Also, I optimized it for mobile, so it's intended for people to be able to play on their mobile phone as well. And this is using React as the front end. And it's using context for state management, and then the backend is all just AWS services. Like I have the actual assets hosted in S3 behind CloudFront and stuff like that. Okay, the question is, can I solve my own puzzle and get back to LeetCode? Dorfin? It's not open source, but I don't know if I'm gonna make it open source, but I could share the code though if you're curious to see how any of it worked. Wording? Is that an English word? Wait, what? That's terrible. That's terrible. Okay, so one of the things that I still need to do, is go through the list of words that could be solutions, and remove ones that literally don't make any sense. Like, how is the solution to that problem wording? So this is unusual, by the way. This is not a good first example. Usually the words that come up are better. Here, I'll play again. Let's see what we're dealing with here. Oh, it is the same word for everyone. I switched over to the unlimited mode. I didn't want to solve the daily word on stream, just in case you were gonna play or someone else was gonna play. But yeah, so I have it implemented so there's two modes where you can switch between the daily mode and the unlimited mode. And unlimited, you can just play as many as you want, and you don't get the. Well, I guess there's a slim chance you could get the daily word, but it's not very likely. So up, maybe this is like uptick. It's so I kind of fucked up a little bit. The answer is no, it's not very popular. And the reason is because once I finished it, it was still, like Wordle was still a pretty big buzz, like a big game. And I should have like shared it around more. But the problem is I didn't want to share it around until I had finished a few more features. Like for example, I wanted to have the stats and stuff, like your daily streak and like your average number of guesses and how many guesses it took you to get, like how many times you got it in 2 guesses, how many times you got it in 3. No, I did not share it on either of those. It's okay though. Like it's out there and it does have some players. Let's see, let's go to the Google Analytics of this website. Yeah, Yeah, I probably should have just threw it out there. So, I don't know. I'm getting maybe like four to five users a day. One of them is me, but there are some people that know about it that are coming back to play every day. So at least there's that. And it can, I mean, it could support, I kind of built it. I built it like production ready. Like it could support a lot of people playing it. Cause like all the assets are hosted on CDNs. There's not really many, all of the API calls are cached. So, a page to list out features for users to vote. Yeah, that could be cool. That could be cool. Honestly, that project is one that I might come back to and work on stream at some point. And so, if that were the case, then you know I could give chat a say in what I work on for it. Okay, so I'm trying to figure out for the maximum sum circular subarray. I'm trying to figure out what needs to change about Kadane's algorithm to support it. So I can just quickly implement Kadane's algorithm again. N is equal to nums.size. And then you have your local max, which is the maximum of the current subarray that you're looking at, which starts off as at nums0. And then you have your global max, which is the answer that you're trying to calculate, which starts off at the exact same value. And then what gets returned at the bottom is ultimately the global max. And then what you do is you iterate through and you update these variables as you go. So I starts off at 1, I is less than n, plus plus I. I think I might have been under the influence of some amount of alcohol when I came up with the idea. But literally, I can tell you what happened is like I was at the time I was playing Wordle every day. And I was really excited about it. And then all these spin-offs started coming out. You know, like there was the Dordle where you could do 2 at a time, the Quartle you could do 4 at a time, the Octortle where you could do 5 at a time or 8 at a time. Then someone made Worldle where you had to guess like a planet, or not a planet, you had to guess a country. And then someone made Global, and then there was the Hurdle where you're like listening. And I was like, man, this whole Erdle thing, you know, little games ending in RDLE is really in right now. I should think of something and like try to get in on this. And so I was just thinking about, I think my approach was that I wanted something similar to Wordle, but different. And so the first thing that came to my mind is like, what if I built a game where it's the exact same game as Wordle, except you don't know the length of the solution at the beginning. Like it could be a 3-letter word, or it could be a 10-letter word, or it could be a 20-letter word. Extraterrestrial is actually one of the words that can come up. It already happened for daily mode, so you won't see it there, but if you play unlimited, extraterrestrial will come up. So then I kind of went from that idea, and I had to, you know, mess with it a bit, which is where I came up with the idea of adding the extra hints. So since you don't know the length of the word, as you do with Wordle, how can I provide some extra hints to guide you toward the answer? And yeah, that's where it came from. So the local max is the max of the current local max. Oh, no, it's the max of... So basically, the idea is that you could start a new array, a new subarray. So it's either numsI, or it's the current local max plus numsI. Yeah, no problem, Nick. So you said that you have 10 years experience in web dev. Are you working for like a pretty well-known company? Like would I know the name of the website that you work on, or is it something a little less well known, I guess, is the question. Then your global max. So this is not the correct solution, by the way. What I'm implementing is the solution to the exact same problem when the input array is not supposed to be considered circular. So it's the max of the global max and the local max. So that this is not the right answer, but the thing is now. Oh, wait. The wheels are turning in my head. Can I just double the input array? Can I double it? Can I just like take the whole array and copy it and paste it onto the end of itself so that it's twice as long, but then all the circular subarrays are represented? You just have to make sure that your subarray doesn't include anything twice. Freelancing? Gotcha. Yeah. I did some freelancing back in the day, but although I'm not actually working for a big tech company now, I was for a while, and now I quit and I've been unemployed for a bit. But for financial reasons and other, it's time to get a paying job again. So that's why I'm kind of in this interview prep grind right now. I'm trying to get a job at Amazon. That's what I'm actively pursuing. So things are going well to that end, but I do still need to prep more on these problems. But I think freelancing can be like very fulfilling too. Like working at a big tech company is not for everyone. Like freelancing, you just have so much more control over your work and your schedule and your tech stack. Like you're in full control, right? Like if you go to work for Google, they're going to tell you what to build and they're going to tell you what to use and they're going to tell you when they want it done. They're going to tell you what time they want you at work in the morning and what time they want you to go home. Like not it's probably a little bit more flexible than that, but that's like the general idea. That's the general idea. Whereas with freelancing, you don't have any of that. I recently resigned as well. My last one was an NYC-based company called Isle as a senior software eng. I'm only doing freelance while I'm looking for a new full-time position. Gotcha. I'm not familiar with Isle. Is that I'm assuming that's a startup of some type. Isle. This right here? I'm assuming this is what you're talking about. Oh, this is like a dating app that's catered to. Is this it? Oh, okay. So it's. I was looking at a dating app called Isle. Ah, okay. Turning any marketing touch point into an in-store sale. Introduce new consumers to your brand, increase revenue per person, and maximize the LTV of your in-store shopper. LTV, that's got to be some kind of industry speak that I'm not familiar with. What is that? Long-term value, maybe? All within their text messages. Okay, so it's like... So... Well, that's cool. Yeah, I mean, obviously, it wasn't meant to be. You and Isle weren't meant to be. I hope I wish you the best of luck in finding the next thing. But it seems like a cool idea. And you get your cash in Venmo or PayPal. Got it. Okay, so my idea is this is my idea. For int I equals 0, I is less than n plus I, nums dot pushback num sub I n times equals 2. So I don't think this is quite right yet, but something along these lines, I think we can get it to work. So interestingly, I bet that there's a test case that this fails for, but it's... Oh, okay, they do have a test case in the examples that it breaks for. So yeah, here's the problem. In this middle test case, 5, -3, 5, I'm saying the answer is 14, when the correct answer is actually 10. And that's because since I basically just concatenate the array to itself, it's possible to find maximal subarrays that are not actually circular. So how do I fix that? I have to keep track of the max length that a subarray can possibly be, which is n. So int like max len. So this is like max len of a subarray. That is n. And so then what we can do is we can come in here and we can make sure that as we're keeping track of our subarrays, we're not exceeding the max length. So max length is n, and then int length is 1. So basically length is the length of the subarray that we're looking at. And since the first subarray we're looking at is just the first element of the array, we start length off at 1. Basically an ibotta. Not super familiar with that either, unfortunately. Save on groceries, household items, and dozens of other purchases. Oh, it's like a cashback. That's cool. Maybe I should be doing more ibotta stuff. Maybe I could be getting a bunch of money. So now that we actually have to keep track of the length of the subarray, we need to change this logic a little bit. Yeah, unfortunately I didn't know about that. So I was working in New York City for 2 years as well. What were the years? It would have been like 2018 through 2020-ish. Yeah, 2018 through 2020 or so. That's an approximate time. And I was working at a company there called Squarespace. The website builder, you know, / CMS. And that was a cool company to work for, but I didn't end up working out in the end. So I quit that job too to work at a different company. So at Squarespace, I worked on their... So it's actually the reason I left is because it's related to what I worked on, but they were designing a brand new version of their website builder, like front end, and also the data model that they were using to represent like customer websites. And so it was a huge greenfield undertaking that a team of like 20 to 30 people were working on. And so I was lucky enough to be able to get on that team and work on the brand new version of the website editor that was supposed to be the future of Squarespace. And I worked on that shit for like a year and a half plus. And then they decided that they wanted to keep the existing version and just make iterative improvements to it. And so they threw away everything that me and the rest of the team had worked on for a year and a half. And so that just really rubbed me the wrong way. And I understand that happens in the industry, you know, to people, but I just was really annoyed that all of the stuff that I had done, I'd written some really cool code, I'd built some really cool features, and they just threw it all away. So that's the moment that they did that was the moment that I went back to LeetCode and started looking for a new job. Oh, you want to know something? You want to see something really funny? If you look at my LeetCode submission history, that life event is reflected if you look in 2020. So if you see here, looking in May of 2020, I suddenly started LeetCoding, like out of literally nowhere. I was like, all right, we're getting back into the LeetCode grind. This period of time here, May through September of 2020, was me looking for a new job while still working at Squarespace. And so that's also kind of what's happening now. Although this time I'm doing it while unemployed. But if you look at my LeetCode history from the current year, you see at the end here, July, these green dots, at least most of them, are from my live LeetCoding on Twitch streams. And so I expect this, I'm going to try to keep this going for a while, at least until I get the job. Okay, so if nums subai is greater than nums local max plus nums subai. So basically what I'm going to do is I'm going to do this max manually now, because I also need to update the length. Thanks brother. Yeah, all I can do is try my best. I mean, so the thing is, like, I know I can get a job eventually. Like, I feel really, very confident that finding employment is something that I'll be able to do. But I'm trying not to settle just yet. You know what I mean? Like, I'm trying to actually land something really hardcore. So that's why I'm trying to get a job at Amazon right now. There's some other companies that I'll try it at as well if Amazon doesn't work out. But then if I can't get a job at like a quote-unquote dream company, then I still feel pretty confident I'll be able to find a job somewhere just because of my experience, you know, my resume and my background and skills and stuff like that. But hopefully settling won't be necessary. Hopefully I'll be able to get something really good, like a job at Amazon would be dope. So if nums_i is greater than, then this means that we restart. This means we restart the array, and the local max becomes nums_i. Oh, sorry, this is wrong. So here length equals 1. Here local max is so here we just increase the length. And local max equals local max plus nums_i. So and then that takes care of this line. The global max doesn't have to change. So and then here's the thing. So this will, if I run this, I should see the same results for the 3 test cases where I pass the first one and the third one, but I'm failing the one in between. So there's another case where I need to reset the length of the subarray. So basically I can't expand the subarray past the max size. So let me do this. So if, let's have else if length is less than max length. So if the length is less than max length, we can do that. Now what if the length equals the max length? If the length equals the max length, then we need to like shift the subarray like a window. I think there's probably some different cases you could do here. No, you can subtract the previous, like you can subtract the first element so that you can add a new element onto the end. Yeah, I think that's right. So, so how do we get the first element? Well, okay, so if length is equal to max length, then it's gonna, the first element is gonna be I minus the max length, right? So, okay, so let's think about this. So we need to remove local max minus equals nums sub I minus length. So if we're at like index 2, so if we have, let's try to make sure we get this right. So if we have like a 1, 2, 3, then when we make it circular, we double it. So we get 1, 2, 3, 1, 2, 3. And that enables us to, like, for example, take this as a subarray. So if we're at index, if we're at index like 2 or at 1, and the length is 1, okay, so I think that might be right. I think this line of code is right. Length minus equals 1. So I wonder if this will just work. So basically, first I tried to see if we need to start. First, you always check to see if starting a new subarray is better. If not, then as long as you can add wait. We do need to check one more thing here. Else if the local max is less than yeah. And then if we get here, then we just remove one from the front, right? Does this work? Okay, this code gets accepted for the 3 test cases we have. I'm not sure if it's completely right though, but I am going to submit. It's not. So we got to debug. We got to do some debugging. Also worthy of note that I solved this problem during my LeetCode grind back in 2020. So May 15th of 2020, it looks like I grinded this problem out for a while and then I got to a solution finally. So let's try to improve on that. Let's try to get fewer wrong answers than last time before we get it accepted again. All right, so I'm gonna use the built-in LeetCode debugger. And where should I set a breakpoint? I think just at the start of at the first line of the for loop. So let's debug. Okay, so we doubled the array. I is 1, n is 8, max length is 4, current length is 1. Local max and global max are both 3. Okay, so let's see what happens at index 1. Huh? Hold on. Okay, so what is local max? It's 3. 3 plus -1 is 2. And so we can tell that that's worse than the current one. So it tries to make the length of the subarray 0. Okay, let me just check to see if this part is actually necessary. Maybe we don't need that check. Okay, so that does help us pass that test case. Let's run it on all the test cases. Okay, so we borked something. Test case 2. I borked test case 2. Okay, so I do have something fundamentally wrong with the code. Let's bring that back. I think we're probably missing a case. We're missing like an if statement. Yeah. I mean, I'm sure that it was optimal. Like, I usually don't. Sometimes I do, but I generally don't move on from a problem without having the best complexity, you know, big O-wise. So I have a feeling that this was linear, and this right here, that the solution I'm working on, is also linear. And then the other thing too is because I'm solving some of these problems 2 years after I've solved them previously, in some cases, I don't exactly know why, but LeetCode has changed the test data, and I've had solutions that are identical to my solutions from 2 years ago that take longer to run. Like, they still get accepted, but the number of milliseconds in this like runtime column has gone up, and I can only assume that that's because they either changed the test data, or maybe the code is running on a slower machine now or something, but they changed something, and so I've been getting worse runtimes for identical code for some reason. Yeah, always starting with a naive approach. Yeah, I do that for a lot of problems. I didn't do that for this one just because I already knew how to do this for the non-circular case linearly, so I'm just staying linear and trying to do it for the trying to incorporate the circular element. So -1, right? -1 is our number of interest, and we're trying to figure out what do we do with it. What do we do? Well, okay, so do we need another case? Do we need another case here for like what? So what am I supposed to do in this case? If I can't improve on the local max, like with the -1 case, so I have 3, and then I come here to -1. Oh, it's supposed to do this. No, it's supposed to do this? Oh, wait. Now I'm confused. Code Wars. I need to check that out. Is that similar to Clash of Code? I've been doing some Clash of Code on stream. I had a viewer in the stream at the very beginning who actually joined for a round, which was cool. Let's see, Code Wars. Achieve mastery through challenge. Training with your peers on code kata that continues. Oh, interesting. Well, oh, I passed the initiation for that. Okay, that's cool. I'll check that out. That might be something that I could incorporate into the stream. So basically, if we have to reset the array, we reset the array. If it's so, this first if is if it's better to reset to a new subarray, we do it. Otherwise, we get here, and we can see that it's better to incorporate numzi into the local max. And it fits, so we can just include it and increase the length. Otherwise, either it didn't fit or it wasn't better. Also, I think here we should probably greedily start a new subarray too. This should be greater than or equal to. Not sure if that changes anything. So now if the local max is greater than or equal to the local max plus numzi. So I think the idea here is that I'm supposed to do this. So in this case, the -1 plus so I've got a 3 so far, and so what are we trying to discover? We're trying to discover that 3 through 2 is the answer, because you do the 3, you do the -1, but you do the 2, and then that comes out to be 4, which is better than just the 3 by itself. Okay, so, okay, let me hide these 2 lines of code again and debug this again. Okay, so 3, we're at the -1, local max is 3. So we step over and we get down, yeah, so the problem is we come down here when actually this is what we should do here. We're supposed to incorporate the -1 into the array. Even though it makes the sum go down, it's still the best local max that we know of. So how do we make it come into here? Why is it not coming into here? Local max. So local max less than local max plus numzi. This is not the correct. Okay, so that. So if I do that and I run the code, it passes this test case. Let's see what because that seems right to me. Let's put all the other test cases back in and take a closer look at the other one that was failing. So 3, 7, -2, 4. Okay, so test case number 2, which is 5, -3, 5. So we're not getting the right answer for this. Oh, okay. So this one is so I'm outputting 7 because my code thinks it's 5, -3, 5. But really, because it's a circular array, the two 5s can be together. So let's debug this one and see what happens. Let's debug it the same way. So my local max is 5, global max is 5. And so at some point, the idea is that at some point we should get to these two 5s, and that should dominate the global max, and that should be the answer that we generate from the problem. So let's see what happens. So we increased, okay, so the local max, so our length goes to 2, and our local max becomes 2 because, so we're looking at this subarray, 5, -3. So global max is still 5, local max is 2, and length is 2. So all of that is correct. We update our global max, it's not going to update, and we come back to the top. Now I is, after I step over that line, I is 2, so we're looking at this 5. We're looking at the 5, and we try to decide, let's see, is 5 greater than the local max plus 5? It is, so this is going to bring our local max up to 7. So we increase the length, and the local max becomes 7. Right. So now what? We go again. Global max becomes 7. We come back to the top. Now we're looking at this 5. And the current length is 3. Okay, so yeah, I think, yeah, this is where the problem is. I just still don't quite see what the problem is. Okay, so it comes in here and it tries to shorten. It tries to shorten it. So what it does is it tries to drop the first 5 out. So the length goes to 2. And the local max goes to 2. Okay, so that actually worked. But oh wait, am I not supposed to increase I in that situation? So basically I subtract. That's gonna increase the runtime of the program, right? Hold on. What happens if I minus I here? Okay, so whenever I shorten this can't be right. There's no way this is right. This gets the right answer for this test case, but whenever I shorten the subarray, I don't want to bring I up. I don't want I to go up. Okay, well, let's try it anyway. On all of the inputs, and then let's submit it. Okay. Alright, so that's not correct, but we did get ourselves a new test case to look at. So this test case, I'm outputting 13 and it's supposed to be 16. I think I don't think this is quite right. I don't think I'm supposed to be stopping the loop when I'm shortening. Pretty bland snack, not gonna lie. It's just original Triscuit. But my stomach was saying, hey, give me something. Okay, there's hints. Let's look at the hints. Thanks. So we already got Kadane's algorithm. What is an alternative way of representing? Yeah. So this is what we did. So basically, case 1 is the subarrays in the middle, which is just Kadane's. Case 2 is that the subarray could be split across the boundary. Okay, let's look at hint 3. Maybe the problem is that I'm trying to force Kadane's algorithm to work for case 2. Should I be handling case 2 separately? So I can run Kadane's algorithm, and I can get the best global max for assuming that, you know, the subarray does not go across the end, does not pass the end, and wrap around back to the beginning. And then once I have that, then I check this situation where the subarray crosses. So if it crosses, here's an interesting idea. So let's just use like 3, -1, 2. So we double it up and we get 3, -1, 2, 3, -1, 2. If the subarray crosses, it's guaranteed to have at least these 2 elements. Because if it doesn't have the 3, then that means that the subarray is entirely over here. If it doesn't have the 2, that means the subarray is entirely over here. So maybe we like, can we find the maximum split across subarray just with one more loop? So we start off with it as 2, 3, and then we iterate up to the end here, improving it by as much as we can. Yeah, that is how to do it. So basically, you take the 3, and then you add -1 to it, and basically you keep track of like what's the best sum. It's like a prefix sum. So what's the best prefix sum of this array, and what's the best suffix sum? Okay, yeah, that's almost it, but then you also need to make sure that you're not duplicating numbers. So for example, if I discover that 3, -1, 2 is great, or if I discover that 2, 3, -1 is good, then I can't use this -1. So let's make it 1 longer, because I think it might make it a little bit easier to reason about. So 5, 3, -1, 2, 5. Okay, so we know that 3 and 5 are in any subarray that crosses the boundaries has to contain 3 and 5. So if we grab the, so then we're kind of looking for a best prefix sum starting at the 3. Is it like sliding window or something? It sucks because Kinane's algorithm, I should just be able to run Kinane's algorithm on this. But the problem is that the length. So it expected 16. Maybe there's a better fix than this minus I. So I'm curious, what happens on this test case if I get rid of the minus I there? Ooh. It's way off. Okay, so if I were to just do normal Kidanes, then I know that the 5 and the 3, if the best subarray is a subarray that's split across, then the 5 and the 3 have to be in there. So you'd start your like best, you'd start your like, you know, your max off at the last number plus the first number. Then we can go to the right and include numbers in the subarray, or we can go to the left and include numbers in the subarray. But we need to make sure that we don't ever exceed the maximum length of the cut across, the split across subarray, which is 4. So it could go 2, 5, 3, -1, or it could go -1, 2, 5, 3, or it could go 5, 3, -1, 2. So let's think about it this way. What if I were to create prefix sums of this? So a prefix sum of this array would be 3, 2, math, 4, 9. So basically, you're keeping a sum as you add each index in. So 3, and then 3 plus -1 is 2, and then 2 plus 2 is 4, and then 4 plus 5 is 9. So you got the prefix sum. Oh yeah. I quit. I quit there. I mean, it was a good company, and honestly, because they pay really well, is the reason I've been able to be unemployed for a bit. But yeah, it's a great company. I'd recommend it to anyone who wants to try, but the project I was working on wasn't really for me. Yeah, I still need to update my LinkedIn to say that I'm not there anymore, but I've been lazy. So what is the suffix sum? The suffix sum is 5, 7, 6, 9. That's the suffix sum. It's like the prefix sum in reverse. So now, how do I get from these two arrays, the prefix sum, and then the suffix sum? There's got to be a way to get from these two arrays to the solution for what the best possible subarray is that crosses the boundaries. What's the difficulty of this, by the way? Oh, only medium? Alright, making me feel stupid. So if I have these, what I can do is I can take the suffix sum and I can reverse it. I'm just trying to keep notes here of what I'm doing. If I reverse the suffix sum, don't reverse. I don't know how to. Don't rev. 3, 2, 4, 9. Okay, so what I'm thinking is, if I have this, then I know that like the subarray is going to be like the sum of it's going to be the sum of one of the prefix sums plus plus one of the suffix sums at the beginning. So basically it could be like 3 plus 5. It could be 3 plus 7. It could be 2 plus 5. But it couldn't go past the halfway point. Well, so basically they both can't go too far. So how would I write that as code? I would start off with my 3 and my 5, which are the middle two elements. And then I could add in the 7 and the 2. And then once I do that, I have length 4. So if I don't add in the 7, I could do these, basically, is the idea. So there's only certain configurations that work. I just gotta code it up in a smart way, but I think that this will work though. So oh yeah, and also these don't need to include the ending one. Like these only need to be 3 long. They don't need to include each other. It's kind of hard to, yeah. So what you actually end up with is this. So you can use so basically you can either use these 5, 3, you can either use the 5 and the 2, or you can use the 3 and the 7. Those are your two choices. So actually that's false. You could use all these, but then you only get the 3. Or you could use all these and you only get the 5. Or you could use 2 from each. Kind of want to be done with this one already. Should I just try to start coding this? I don't have the idea like fully formed in my head yet, because the problem is these prefix and suffix sum arrays are useful and I can get them fairly easily, but then like how do I use that? How do I get the answer? So maybe I start off assuming that you're just using the 3 and the 5, and then I'm like, I look to the right, and the sum goes down with the 2, but it goes up with the 4. Oh, in this case, the best is actually the same both. So you could use the 3 and the 6, and you get 9, or you could use the 5 and the 4. You also get 9. Is that a coincidence? Is that just because of the way the problem is? So if I use like, if I use this, no, it's not a coincidence, because it's a lot of the same elements. It is the same elements. So 5, 3, -1, 2, yeah, that comes to 9. And then what I was trying to observe is that if you go this way and you do -1, 2, 5, 3, it's also 9. So it's just the same. It's the exact same sum subarray. But then that only works if you're using a subarray that's as long as possible, which is length 4, which is just the same as it's just the same as the original array. But then if you're using a subarray of length 3, then you'd be looking at either these or these. It wouldn't be the same. So that technically means that we can drop those out as well. But for a longer array, you'd still have a bunch of things to consider here. So basically, if we did the 2 and the 7, that comes out to 9. The 2 represents 3 and -1. And the 7 represents 5 and 2. So yeah, so that represents 2, 5, 3, -1, which again, that's just the input array. So we just don't need to consider subarrays that are the same length as the array, because Kadane's algorithm will find that. We need to consider subarrays that are at least one shorter than the length of the input array. So I still think that I should be able to somehow use Kadane's on the concatenated array, but there's something wrong with the logic. Maybe reducing the length here is not the answer. Do I just reset? What happens if I no, it's definitely not right, but like what if I put those lines of code there? Yeah, it's already not right. So if local max if numsI is greater than or equal to local max and numsI, we reset. Otherwise, if we haven't reached the max length, we have reached the max length. I think there's probably something different I can do here in this last else. So for if the subarray we're looking at is the max length that it can be, which is the original n. There's also no point even letting it get that big. At most, it just needs to be one smaller. But that's not going to fix it. Okay, so that I think that was a fluke. That makes it past that test case, but there's no way that that's right, though. Okay, yeah. So it thankfully one of the other test cases that I've been looking at caught that. Specifically this test case here. The fuck, dude? Okay, let's debug this, see if we can figure out anything insightful. So we splat them together. Max length is 3. Okay, so local max goes to 2, that's correct. Oh wait, that's wrong. Wait, no. We do need to go, because this normal cadence needs to see the whole array. So we can't just stop when we hit the max length. So that was dumb. Okay, let's take another look then. So we include the -3, which brings the local max down to 2. Yep. We've seen that already. Looking at the negative... Wait, no, we're looking at the 5, the second 5 now. And that's going to bring our local max to 7. So we already saw all this. The global max becomes 7. And now we're at index 3, which is the third 5. And the problem is the length that we have is 3, and that's because of these. So what happens? It comes down here, it subtracts the 5 out of the local max, and it subtracts 1 from the length. Okay, and if I recall correctly, this doesn't work because I'm not freezing I in that case. But then if I did this, that makes this test case work. But then it's the other test case the one that I got when submitting the problem, that broke. Because it's supposed to be 13. Oh no, we said 13, it's supposed to be 16. So let's actually debug through this one then. See if we can figure out what's going on. So, local max is 5. We come back into the loop. Then there's an 8. This is going to give us a local max of a local and a global max of 13. And so hold on. So the output was supposed to be what? 16. And I said 13. So these two negative 9 cancels out. Now what am I at? I equals 4. I'm at the 9 here. Okay, so that brings the local max back to 14. The length is 4. Now I is 5, we're looking at the negative 7, so the local max is just going to come down to 6. Now we're looking at this 3. The local max is just going to come back come back up to 9. Length becomes 6, so everything looks good so far. The negative 2, the local max becomes 7. Okay, let's keep going. Okay. I don't think this is right at all. I don't think this code is right. I don't think you're supposed to use cadence on the concatenated array. And because I've been staring at this one for so long, I'm just going to try to get a hint to what the solution is for crossing over. So I already know that. Subarrays of circular arrays can be classified as either one interval or two interval, depending on how many intervals of the fixed size buffer A are required to represent them. Right, okay. Okay. So this is the insight right here that I need to know. I'm not going to look at the code though. So using Cadene's algorithm, we know how to get the maximum of one interval subarrays. So it only remains to consider two interval. Yeah. I figured that part out. I just didn't know how to do the two interval part. So let's say the intervals are 0 to I and j to a length minus 1. Wait, hold on, where is that coming from? Let's try to compute the ith candidate, the largest possible sum of a two interval subarray for a given I. Computing the 0 to I part sum is easy. Yeah. So this is the prefix sum that I was talking about. And R sub j What is R sub j? R sub j is max of t sub k, where k is greater than or equal to j. So that the desired ith candidate is a sub 0 through a sub I plus r of I plus 2. Oh, wait a minute. I feel like I kind of understand. So the prefix sum array makes sense, but what you really want to keep track of is not the current sum of the prefix, but the best prefix sum you've seen so far. Okay. I think I can get this. Oh, you're good, man. I'm still fighting with this one. I just glanced at a little bit of the solution without actually looking at the code, and I think I understand what I need to do now. So so this is wrong. So that's basically the conclusion that I kind of thought, but I wasn't sure. But you cannot use cadenes to figure out the best subarray for crossing, back around. You just use cadenes to find the best subarray within the array, and then you have to write a different algorithm that's still linear time to find the best subarray that crosses. And it does use prefix sums and suffix sums, except that you don't actually, your prefix sum array is not the actual prefix sum. Your prefix sum array is the best prefix sum that you've seen so far. Yeah, because that if you keep track of the best prefix sum you've seen so far for each like then that means that your subarray, you're basically saying that your subarray could end anywhere within a specified set of indices. Okay, so I think I can code that, and I'll explain more as I do. But let me just use the restroom real quick, and then I'll come back and I'll code that. So one sec. Okay. I'll be glad to move past this problem. So we don't actually need to do any of this. We don't need to double, let me exit the debugger. We don't need to keep track of the length. We just need to do normal cadenes algorithm. So I can delete all this, and then I can do local max equals the max of num sub I and local max plus num sub I. And so now we're back to just regular cadenes algorithm. which should pass some of the test cases, but obviously not all of them. Yeah, that's exactly what we see. So this right here, find global max for standard subarrays, I guess. And then we have another part where before we return global max, find global max for crossover subarrays. And then, you know, return the final global max. I mean, it's not a useful comment, but just to kind of sort the code, organize the code a little bit. So for the crossover subarrays, what I'm going to create is I'm going to create a prefix sum, and I'm going to create a suffix sum. So vector of int prefix sum of size n. And a prefix sum is really easy to write. So int, you just have like int sum equals 0, and then for oh yeah, so actually an even easier way to write it is for int x in nums, sum plus equals x, and then prefix sum dot pushback x, pushback sum. Except this is not quite what we need. We need prefix sums, but we need like best prefix sum seen so far. So int best sum equals 0, sum plus equals x, then best sum is the max of best sum and sum, and then what we put in the prefix sum is the best sum. And so we'll rename this to best prefix sum, and we'll call this current sum. So we have so this is kind of like local max and global max. So this is how you implement it for the prefix sums, which is going to help us figure out the answer for the global max for a subarray that crosses over the end of the input and back to the beginning. So current sum plus equals x. The best sum is the max of the best sum and the current sum. Yeah. Another way to write this would be, no, you know, this is fine. We need to do the same thing now, but we need to make a suffix. We need best suffix sum. So best suffix sum starts off at 0, and now here this one we have to do a little differently because we're going from the back, so we can't use pushback. Well, okay, so down here I had talked about creating the suffix sum and then reversing it, and that might actually still be useful, honestly. I think that might still be useful. Yeah, I think it's still useful. So because I want the suffix sum to be reversed, I can still do pushback, but I'm going to be iterating from the end of the array. So int I equals n minus 1, I is greater than or equal to 0, and minus minus I. Current sum plus equals nums of I. And then best suffix sum pushback. Okay, so we can do that. Let's shorten this a little bit here. Clean up. Let's run the code. Best prefix sum. Okay, so the code runs. I wanna check these out real quick, so I'm gonna log them. So for int x in best prefix sum, cout x followed by a space. And then we'll have an end line. We'll have an end line. What's the test case that's failing? The 5 -3 5 test case is one of the ones that's failing. So, and that's because the answer is obviously 10 by taking 5 from the end and 5 from the beginning. So let's just look at that test case and let's see what the prefix and suffix sum looks like. So the test case is it's a palindrome, which actually makes it a little bit difficult to see whether or not stuff's working. Okay, so if I introduce a 2 in there, then the answer goes from 10 to 12, right? Because you can take this 5, and then you can take the 2 and the 5 from this end. So for this test case, we would expect to see 12. Let's run the code. Right. So the prefix sum 5 5 5 9. That looks right. What about the suffix sum? The suffix sum should be 5 7 7 12, which is the answer. But okay, so something's wrong with the way I'm calculating the best suffix sum. Because it should definitely be 5 7. So I is n minus 1, I is greater than or equal to 0, minus minus I. Current sum plus equals nums I. Best sum is the max. Oh, okay. Sorry, I'm just being dumb. This should be best suffix sum right here. So now when we run the code, we should see something slightly different. Yes, okay, so that looks good. So now the idea is if you use, let's say that you use this 9, actually the 9 doesn't even matter, you fully ignore it. If you use this 7, then you can only use this 5. If you use this 7, then you can use that 5. If you use this 5, you can use that 5. So there is a sum here that comes to 10, which is yeah. So now I think we can check all of the possibilities now. We can check all of them. So let's get rid of this. And for I equals, how do I want to do this? 0. I is less than, we can't use the last elements. So I think it needs to be less than n minus 1. So and then plus plus I. So what I'm doing now is this I is going to be iterating over the prefix sums and checking using them. And so basically if I look at this index of the prefix sum, this 5, then that means that I have to look at this index of the suffix sum. So I think I can do it in one line of code. So global max equals the max of global max, and the best prefix sum of I plus the best suffix sum of, so if I is 0, then it needs to be n minus 1 minus n minus I minus, so if n is 4 and I is 0, we want to get 2. So it might actually be this, which is kind of confusing. Max of global max and that semicolon here. Okay, so the good news is that passes that test case. What about all the test cases? What about all the test cases? Ooh, something's still wrong. So we get -2. How do we get -2 for something? We get -2. Oh, no, we're saying 0. We're saying 0, but the answer is supposed to be -2. Okay, so I have some kind of case where I think I'm allowing my code to consider a subarray of length 0, which obviously has a sum of 0. Bro, let me copy that test case, dude. Alright, so it's this test case right here. So I run this. Okay, so the first thing I want to see is what's the global max after I run cadence. So I'll leave a breakpoint here, and then I'll leave a breakpoint here as well after I create the prefix sums. So prefix and suffix. So debug. So after running cadence, the global max is -2. Okay, so basically after running cadence, we're still right. So there's a problem where we're increasing global max to 0 after, when we're taking into account our prefix and suffix sums. So let's continue. Oh, I need to start the best sum off at basically -infinity, since the code has to handle negative numbers and negative sums and stuff. So this needs to be numeric limits of int min. That's one way to grab an infinity-like number in C++. Then I'll do the same here. Okay, does that fix it? Okay, that fixes it. So let's run the code on all the test cases again. Okay, so we get accepted for all the test cases we know, which is these three examples, and then 2 test cases that we got from these 2 wrong answers. So, moment of truth now. Is my code right? That's how you do it. We get accepted. 91 milliseconds. Slower memory-wise, and a little worse memory-wise than 2 years ago. A little bit slower runtime-wise as well, but like I said, sometimes they change the test data over time. It's also possible that something changed about the running environment, or the way that the timing is measured. So I don't care about that. I don't care about seeing my runtime go up by 30 milliseconds. There's a few more things that I'm interested in before I leave this problem behind for probably a really long time. The first thing I'm interested in is I want to look at my JavaScript code that solved the problem from 2 years ago. All right, Nick, take it easy. Thanks for hopping in the stream, and again, thanks for the follow. Really appreciate it. I want to look at my JavaScript code. Wow, it looks way better. Looks way better. So I have this variable total sum. Oh, what? Okay. This is wacky. This is wacky. I see what my code is doing, and I'm kind of mind blown by it. So what my code is doing is it's doing cadenes, two cadenes at the same time. One where it keeps track of the max global value, and one where it keeps track of the min global value. Then, if you know what the min global value is, then you know what the max possible subarray is that crosses over, because it's just the total sum minus that. So if the total sum is the min global, return max global. Otherwise, return the max of the max global and the total sum minus the min global. Okay, and so the reason you got to take this into account, total sum and min global, is because the whole array could be negative. If the whole array is negative, if it's like 3 negative 1s, right? Your total sum is going to be -3, and your min global is going to be -3. And if that's the case, you actually want to return -1, because subarray of size 1 in that array has a sum of -1. So you return the max global. Otherwise, it's whatever the max is of the max global and the total sum minus the min global. This is pretty dank. Not gonna lie, this is pretty dank. I also, 2 years ago when I first solved this, I actually doubt that this was my original idea that I came up with during the contest. I probably knew cadenes, but this whole keeping track of the min global as well, using the exact same algorithm that for cadenes, but just using a math.min instead of a math.max, and then using that piece of information to figure out what the true global answer is for the circular subarray. That's pretty whack. Let me update my code to do that, just because I want to see how that affects the runtime and the memory. It's going to affect the memory, I think, pretty significantly, because right now I have 2 extra vectors of ints that I'm creating, and doing it the other way, it makes that not necessary. But also, I'm doing work here to compute these prefix sums and suffix sums, and even though my overall runtime is still linear, and that's the optimal runtime, I'm still doing more operations overall than if I were just doing it the same way I did it last 2 years ago, where I did the double cadenes and kept track of the max global and the min global. So I'm going to update my code to do it that way. Even though I didn't think of the min global thing, I am still pretty happy with that I was able to get this. Like, this is still an optimal runtime. It just is not quite as fast, operations wise, as as doing the min global and the max global. So if I look at the solution page again, here's what my theory is. My theory is that okay, so this is my code, right? They're using max right and left sums. So they're doing prefix and suffix sums as well, and that's how they handle it. But then I bet if I scroll down more, I'll see something that I looked at Ooh, prefix sums in monoq. Prefix sums in monoq. And then the Cadane sign variant, this is going to be constant space because you don't use any additional space. And this answer, this answer uses Cadane 3 times. Okay, and then there's the Cadane's min variance, which is probably, yeah. How long have I been live, by the way? 3 hours. I'm gonna do a bit more. Unclear exactly what. Oh, I did open some other pages here, didn't I? Like, I've got these other next grader elements that I could look at, and there's also the maximum product subarray. So there's some interesting DPs that I need to review too. I think they're on LeetCode, but for example, edit distance. I'm sure LeetCode has that. Yeah, edit distance. Edit distance, very, very iconic dynamic programming problem, but it's not an easy one. It's you can see LeetCode labels it as hard. And then the other one that's kind of iconic is the, I think it's the longest common subsequence. And you can solve this problem efficiently using DP as well. Look, related topics, yeah, dynamic programming. Okay, so LeetCode has this marked as medium, but they have edit distance marked as hard, which I find interesting. But so I don't know if I'm gonna look at those today, but these are coming up. These are coming up in the next couple of streams. I'll definitely look at edit distance, and I'll definitely look at longest common subsequence. Maximum products, I probably should do that one because I'm trying to make my way through. Here, I'll show you what I'm trying to do. I'm trying to make my way through the ultimate DP study plan. So I've done a bunch of them. I just got this one. You can see they've marked it as completed. That's the one that I just solved, although I'm going to solve it better in a bit. But then if we look at some of the other dynamic programming problems that are coming up, oh cool, so there's a bunch of these other ones that are interesting. There's the longest palindromic substring, there's the longest palindromic subsequence, there's the longest increasing subsequence, and then you've got down here, so they're reserving these for day 19, so I'll probably wait till I've done, I guess, what they consider to be the prerequisite questions. But then they do get to the two that I just mentioned. So on day 19 is longest common subsequence and edit distance, both of which are very iconic dynamic programming problems. Coin change is also a very well-known problem. And then more here, like some that I'm not familiar with. I don't know what integer break or perfect squares is. Combination sum. I think I've solved this one. What is this? Will they not let you open the problem page if you haven't unlocked it yet? That's kind of silly. Watch this. LeetCode combination sum. It'll take me right to it. Oh, combination sum IV. Yeah, so this one I got. Whoa, fast, dude. I got it fast in April of 2021. So like a little over a year ago, I solved this problem. So anyway, that's coming up. If I got it that easily, it can't be that difficult. Okay. Why do they have word break and trapping rainwater in here when they don't have dynamic programming as tags on the problems? The world may never know. Okay, let me just quickly optimize my maximum circular subarray. So this works, and I'm happy that I was able to get the problem accepted with this, because even though I did grab a hint from the solution page, I did come up with this code myself. So next, let's do it the other way. So local max, local min, global max, this is kind of a fun way to do this, completely unnecessary and quite possibly difficult to read, but and global min equals global max. So basically everything just starts out at nums 0. A more readable way would for sure be this. Okay, so we got local max, local min, global max, global min. And so now we can copy and paste these two lines of code. And change the variables. So local min is the min of that, and then global min is the min of the global min and the local min. And then the last thing is we're also keeping track of the total sum. So last but not least, we increase the total sum in here by nums I. Are we going to save fractional amounts of CPU cycles by storing nums I in a local stack variable? Probably, right? Probably. Is this faster is the question. Who cares, dude? Apparently I do, because I'm doing it anyway. So I just want to beat my JavaScript solution, man. I should be able to beat it with C++. Okay, so alright, so we have all that. That should be... Wait, it's not quite right yet. This needs to be local min. Okay. So then we have to handle the edge case where everything in the array is negative. And you can tell when everything in the array is negative because the global min will equal the total sum. When that's the case, you want to return the global max, which will be, it'll basically just be the least negative number in the array. Then once you've handled that edge case, you're just returning the max of the global max and the total sum minus the global min. And this is pretty much line for line what my JavaScript solution was from 2 years ago. Okay, yeah. So obviously it's accepted. It's really fast. It's faster than 95% of C++ submissions. As far as runtime goes, though, it's interestingly comparable to the JavaScript solution from 2 years ago. I kind of want to grab the code from this JavaScript solution and just run it again, because I bet they also changed the test data and stuff like that. JavaScript definitely is a slower language than C++. One of them runs on a runtime, which is JavaScript. One of them, you know, if you compile it the right way, it compiles all the way down to machine code that runs on directly on your processor. So let's grab the JavaScript code from 2 years ago and let's run it again, just to see how fast it runs. Because there's no way that the C++ solution is better. Okay, yeah. So this is what I was talking about. So it's the identical code. Like I literally copied and pasted it from my accepted submission 2 years ago. And now when I run the exact same code, it takes 122 milliseconds to run. And the C++ code runs faster than that. So that's literally all I wanted to see. What is best meeting point? Why does that sound fascinating to me? It's a red problem, so it's probably too hard for right now. I've been going for a while. I've been going for 3 hours. 3 hours of LeetCode in a day is plenty, but I will do a little bit more. Let's at least see. Okay, let's close some of these tabs. Let's see what this is. What is this? Best meeting point. First of all, have I done this before? I have not. I have no submissions on best meeting point. So, given an m by n binary grid where each one marks the home of one friend, return the minimum total travel distance. The total travel distance is the sum of the distances between the houses of the friends and the meeting point. Oh. Okay, yeah, and the distance is Manhattan distance. So basically, for this example, the meeting point's probably here in the middle, right? Because he can get there in one step. These guys can get there in... Wait, is this just Floyd-Warshall? All pairs shortest path? So Floyd-Warshall will give us all pairs shortest path in cubic time, right? N to the third, triple for loop. Once we run that, we can go through every cell and try to see if it's the best meeting point. If we do that, so we would go through the cells one at a time, right? And so for each 0, we would iterate through the friends' houses and sum their distance up to it. Okay, so that might be right. I don't have Floyd-Warshall memorized. It's one of the algorithms that I plan to review soon. So let's just try to get an idea as to whether or not that's even remotely right. So the way I'm going to do that is I'm going to look at the related topics. Array, math, sorting, matrix. So that doesn't sound like Floyd-Warshall at all. Similar questions, shortest distance from all buildings. Okay, and what's the first hint? Try to solve it in one dimension first. How can this solution apply to the two-dimension case? Okay. So for the one-dimensional case, can you just average the indices of the ones? So if you were to, let's say that there's only 2 ones, right? If you average those, you find the midpoint. If you have 3 ones, you average those. I mean, obviously it's not the midpoint, but is it the answer though? Okay, I don't think I'm going to do this one right now. So I've done several LeetCode problems today. Okay, so this problem right here, next greater element 2. This is level 2, Mark 2, whatever you want to call it, of the next grader element series, and I solved the first one earlier, and I used a stack. I used a stack as a monotonic stack to help me figure out what the next greatest elements are. So in this one, the array is circular. Okay, so I think what's interesting is a problem that I just attempted a few minutes ago, the maximum product or the maximum sum of a circular subarray. I was trying to use Kadane's algorithm on the input subarray concatenated to itself, so it would handle the crossing part. That doesn't work for that problem. That did not. I tried it. It did not work. I ended up finding a correct solution and then a much better solution, a much more beautiful solution. But for this problem, that might work. For this problem, I might be able to take nums, stick it onto the end of itself, and just run the next greater element algorithm on it. Fuck it, let's try that. If that's right, then this, if that's correct, then this shouldn't take too long. So int n equals nums.size. I wouldn't mind knocking out a problem with relative ease. So if what I just described is the solution to this, then I should be able to do that. So first we need to double the array. So for int I equals 0, I is less than nums.size. You don't have to double the array, but it makes it a little bit easier, I think. I think it will make it a little bit easier. So nums.pushback. Oh, is this supposed to be in place or do I return it? No, it's, oh wait, in place doesn't even make any sense. It's a completely different set of numbers. Pushback nums sub I, and then we get n times equals 2, or shifted to the left one time. For no apparent reason, I'll do it that way. So what else do we need? We need a stack of ints, which is the monotonic stack, and we need our answer. So vector of int answer size at size n. That's what we return. It is the answer, but I'll just rename it to NGE because it is the next greater element. Stack of ints. So let's do int. Let's call this. Let's have a different variable for this. So we'll have n basically represent the original value of n, and then m represent the size of the doubled thing. Okay, so now we iterate backwards from the end. So for int j equals m minus 1, j is greater than or equal to 0, plus plus j. Sorry, minus minus j. While we need to pop off the stack, while the stack is not empty, and what's on top of it is less than. Or equal to. Nums sub j. Oh, sorry, this should be mono. Mono dot pop. Then down here we're gonna have mono dot push. Num sub j. Okay, so now here's the thing: the NGE of this number is either what's on top, it's either, so first we gotta figure out if mono is empty. So if it's empty, the NGE is -1. Otherwise, the NGE is what's on top. So mono dot top. Now, we only actually need the NGE though if we're within the range of the output. So if j is less than n, then NGE of j equals NGE. What do we call this? Let's call this x. Equals x. Time limit. Oh. So I less than nums.size doesn't work there because nums.size is actively changing as I push stuff onto the back of the loop. Okay, so use the example test cases. We get right answer for those, and we get accepted. Okay, so what didn't work for the maximum sum subarray, circular subarray, does work for next greater element Mark II, where we can just stick the array onto the end of itself and do a normal next greater element algorithm using a monotonic stack. So that worked. Let's take a look at the solution though. So brute force using double length array, time limit exceeded. Okay, so it does double the array. Approach 2 is the better brute force. Okay, so yeah, you can use the modulus operator as well to traverse through twice. Approach 3 using the stack. Okay, yeah, so with their stack solution, they're doing the same thing that I'm doing, except that they are making sure, they're not doubling the array, they're just using the same array, but using mod. Yeah, they're using mod. So that gives you time complexity of n and space complexity of n because of the res. Okay, so that works. That works. So that's good. Knock that one out. Then there's next greater element Mark III. So let's take a look. Not fully committing to doing this yet, but let's see. Given a positive integer n, find the smallest integer which has exactly the same digits existing in the integer n and is greater in value than n. If no such positive integer exists, return -1. Oh, is this a permutations problem? Let's look at the related topics. Okay. Apparently, this is 2 pointers. Okay, so let's think about it. Let's say you had a number. I don't know. Let's say you had this number. And let's just say that it starts off as 15 at the end here. The answer is somewhat easy to see. The answer is that you swap the last 2. So instead of 15, this becomes 51. So none of this changes. So you're still in the fuck that is that even 1.2 million area, right? Yeah. But you've just increased from 15 up to 51. So you've gone up by 36? Yeah, you've gone up by 36. And so I think that the algorithm is going to utilize that you want to try to fuck with the smaller numbers first. Now, in the case of 12, obviously you're just reversing them. In the case of 21, the answer is doesn't exist. So I think the 2 pointers are going to be like pointers pointing at the end and trying to see if flipping them makes the answer flip it, like. Okay, I don't think I'm going to solve this one today. I want to look at something slightly different, but I'll keep this tab open and I'll probably end up looking at that tomorrow. The meeting point question, I'll add it to my list, but I'm not going to solve that. Product subarray is a valuable one to do, so I'll do that tomorrow. So what I want to do is choose something from Algo Expert next. So here I have Algo Expert open, and so I want to choose something from here. So we solved all the easies. Medium, we're at 14 out of 55, and hard, 3 out of 46. So there's different ways to approach this, right? What if I just try to what if I try to grind out all the problems? Like, what if I do mediums, and then once I solve all the mediums, I go to hard? Or there is group by category, and so we could look at arrays, or we could look at binary search trees, or binary trees, or dynamic programming, or famous algorithms, graphs, greedy algorithms, and heaps, linked lists, recursion, searching, sorting. We solved airport connections the other day using Karasaju, something like that. His algorithm for finding strongly connected components. It would be interesting to try like a hard or a medium graph. What about this? What about Boggleboard? Let's take a look at Boggleboard, but let's also not commit to it yet, because where's the famous algorithms section? I feel like doing a topological sort could also be good practice. What else? Suffix try construction. That doesn't sound too hard. Multi-string search. Stacks. Okay, so this one we just solved on LeetCode. Next greater element, I'm sure that's probably the same. Non-attacking queens. Number of binary tree. Something. Generate div tags. Lowest common manager. That sounds like a workplace version, like a workplace themed version of lowest common ancestor, but I'm not sure. Quick select. Okay. Let's cycle in graph. It's always good to be able to find a cycle in a graph. Let me open that too. Although I don't know. I'm not doing all three of these right now, but I just wanted to pick some out for to do soon. So Boggle board. Let's take a look at it. You're given a two-dimensional array of potentially unequal height and width, containing letters. The matrix represents a Boggle board. You're also given a list of words. Write a function that returns an array of all the words contained in the Boggle board. The final words don't need to be in any order. A word is constructed by connecting adjacent horizontal, vertical, diagonal letters without using any single letter at a given position more than once. Oh yeah. Okay, so this question I just solved on LeetCode. This question is LeetCode's word search 2 question. So I just solved word search 2 yesterday, I believe it was, and it's the same. They call it word search 2, but it's the Boggle board. So the way you solve this is by creating a trie out of the input words and by doing a backtracking search through board. Also, I have a question about whether the words in the word list are unique. Or if a word appears multiple times in the Boggle board, I think you just return it once, right? Because that fact enables you to optimize the solution. Okay, I think it's not very explicit in the description, but I think when it says return an array of all the words contained in the Boggle board, I think that means that you can dedupe them. You only have to return the first one you find. So I already know how to solve this. I'm just curious what their hints are. Two separate problems. One problem involves traversing the Boggle board in such a way that allows you to construct strings letter by letter. The other part involves actually comparing the strings you construct in the board against words in the list you're given. For the second part, what data structure lends itself well? So the answer to that is a trie or a prefix tree. Try creating a trie. This will allow you to compare letters in the Boggle board against all input words in constant time. How can you efficiently traverse the Boggle board to construct all potentially valid strings without counting letters twice? Backtracking. Treat the board as a graph. Traverse it in a depth-first search-like fashion, checking if letters are contained in the trie, and traversing the trie simultaneously what makes sense to do. How can you keep track of the letters you visited in order to avoid erroneously counting some of them twice? Keeping in mind that you only want to mark nodes visited in a single branch of the graph you're traversing. Try marking nodes. So and it's gonna be so solution. Their solution. So they have the explore function. Okay, so I guess... So it is backtracking. So they don't actually... It looks like they don't say the word backtracking anywhere. But this is how you can tell it's backtracking. Is because of how they mark the tile as visited before they go into it, and then they mark it as not visited when they come back out. I would consider this backtracking. Maybe the technical definition of backtracking is it's not. Let's look at some of these other ones. So the simple DFS. Are they making a try? Interesting. Yeah, I mean, there's several different approaches. So Boggleboard we know how to do. Okay, let's take a look at cycle in the graph. You're given a list of edges representing an unweighted directed graph with at least one node. Write a function that returns a boolean representing whether the given graph contains a cycle. For the purpose of this question, a cycle is defined as any number of vertices, including just one vertex, that are connected in a closed chain. A cycle can also be defined as a chain of at least one vertex in which the first vertex... Okay, so just a different definition. The given list is called an adjacency list, represents a graph. Also note this graph may contain self-loops. A self-loop is an edge that has the same destination and origin, and that's a cycle. For more detailed explanation. Yeah. So I don't know if I'm going to code this up. I will code this up at least tomorrow, like at the latest, but let me just think for a second. So DFS, right? So basically you want a DFS, and if you at any point during a DFS reach a node that you've already visited in this branch, then there's a cycle. So I think this is the algorithm where you have to keep track of nodes that are fully visited and nodes that are partially visited. Yeah, I think that's okay. And then topological sort is also, you can solve it using DFS as well. I do want to solve both of those. Do I want to do anything else today, though? That's the question. Do I want to do anything else today? Laptop rentals? I don't know. Maybe I group randomly. That's interesting. Group by difficulty. I don't know. What's one that I can just throw together real quick from the medium section? Maybe breadth first search. But I've already done a bunch of BFSs recently. No, I should do something else. Let's go by category again. What have I not fucked around with too much? Binary trees, I honestly haven't done a whole lot. Dijkstra's algorithm is an algorithm always worth reviewing. Dijkstra's algorithm is a single source shortest path algorithm that works on graphs, weighted directed graphs. Probably undirected too, honestly. There's no reason why it wouldn't work on undirected. Weighted graphs. But the catch is that the graph cannot have negative edge weights. So if you have a graph with negative edge weights, you have to use a different algorithm, and the one to go for in that case is Bellman-Ford. I don't remember what the Knuth-Morris-Pratt algorithm is, by the way. I need to review that. Dijkstra's algorithm. Yeah. I think I'm actually getting. I think I am good on interview prep for the day. I've been going for 3 hours and 37 minutes. That's plenty of time. I'll be back tomorrow with the same. I'll start off with probably some Clash of Code, and someone had recommended Code Wars. I need to check out what that is. Earn ranks and honor, tap into the collective wisdom. I mean, this all sounds great. So I'll probably look at some Code Wars as well, and then just jump right back into the LeetCode. Pardon me, the LeetCode and Algo Expert. Problems that I definitely intend to solve tomorrow are probably these 3 Algo Expert ones. I should do the topological sort, the cycle in the graph, and Dijkstra's. We'll definitely be doing more dynamic programming. So what's coming up in dynamic programming? Well, there's going to be the maximum product subarray, and we also have next grader element 3. Have I solved that before? No, that's it's not monotonic stack, but it is worth looking at, I think. And then maximum product subarray, and then there's all these other monotonic stack problems. I'll probably take a look at. Okay, but yeah, that's it for the stream. Thanks to anyone who was here watching. I do appreciate it. This is not the only type of coding that I'm going to be streaming live, by the way. This is just the grind that I need to do right now as I prep for job interviews. So once I get a job, though, I'll continue doing LeetCode and competitive programming stuff on stream, but it'll be much less. I'll probably just focus on weekly contests and things like that, and then I'll replace the majority of the content that right now is this with actual software development, because I want to develop some. I have some web apps, and I want to create some new web apps, and all of that I'd like to work on live on stream, and I think that'd probably be really fascinating for people to watch. So at least that's the hope. Yeah, again, that's it for the stream. Thanks for the follow that I got today. That was from Nick Dot, who I don't think is here anymore. But anyone else who was here or is still here, consider following. I would greatly appreciate it. And other than that, I'll be back tomorrow with more of the same. So catch you later.